Okay, we're going to conclude our chemical bonds review here with intermolecular forces and state. We are going to discuss some of the forces that determine some of the properties based upon bonding forces within matter. So we're going to begin by reviewing that ionic, covalent, and metallic bonds hold groups of atoms together as one molecule or compound, okay, one thing. So these are internal, okay, internal or intramolecular, inside the molecule forces, intramolecular forces. What we want to consider are the attractions that hold molecules close to each other, okay, and these are intermolecular forces. Now we're not going to explore them in incredible depth. We're more just going to consider how solids, liquids, and gases relate to each other in terms of intermolecular forces and a couple other properties. So to start, we're going to talk about solids. The first thing is when you think of a solid, you should consider that a solid is tightly packed. Okay, all of the matter has been forced together into a very, very, very small space. So a lot of matter, small space. So we would say solids have a high density. Okay, they're very dense. We should also consider the ways that they can move. Okay, so solids, while solids are moving, typically their motion isn't perceived with the naked eye because it's very limited. Okay, so we have restricted motion, and it's typically seen in the form of vibrations. Now, we also want to consider what sorts of shapes are these things able to take on? Well, since our motion is pretty much restricted, we only have these small vibrations. What we find is that solids are able to hold their own shape. And the explanation, okay, the reasoning behind this, it has to do with the outside forces, the forces between molecules, these intermolecular forces. So when we consider the intermolecular forces, since motion is restricted, they're packed together tightly, and they can hold their own shape, we assume that they must have very strong intermolecular forces. So an image of this, kind of an illustration, would be we have this grouping of very, very tightly packed atoms, and they could form let's say like a small pea-sized amount. And the thing to be aware of is that because of this restricted motion, because of these strong intermolecular forces, it's going to retain this spherical shape with this grouping of atoms. Now we're going to talk about liquids. Liquids, again, they're pretty close to each other. Okay, like liquids are dense. However, if you compare them to solids, they aren't nearly as dense. Okay, so they we could say that they have about a medium. If you were to kind of designate it's a high density or low density, these aren't low density, where they're kind of in the middle. So a medium density. We want to consider now the motion of liquids, and you see, like in a bottle of water, that the molecules are in motion. They're in visible motion. However, they are still kind of moving together, okay? So they're able to freely move, but they're freely moving around each other. So they are freely moving, but they freely move around each other. In terms of the shape that liquids take, if you have liquids and you pour them, okay, liquids are said to flow, okay, that's that free motion. But if you have them on a flat surface, what they will do is collect into a pool, or if you put them in a container, what they will do is they will take the shape of their container. So they take the shape of their container, and because they are dense, gravity has an effect. They're going to sit on the bottom of the container. So a way that we can kind of visually show this is we have these molecules, and they are again still close to each other. Not as close as they were before, but they're still very close, and they're, falling on each other, back and forth, moving around each other. But you find that they kind of sit at a level, and they're all going to be at the bottom of our container. Now lastly, we're going to discuss properties of these gases. Now gases, they stay far away from each other. So we would say that gases have a low density. Gases, in terms of their motion, they move completely freely. Okay, so they freely move in random directions. Okay, so they move randomly, and they move very, very fast in these random motions. In terms of their shapes, okay, what we're going to see here is that our gases, they really don't have any definite shape. However, if you put them in a container, they will completely fill their container. They will expand and contract to completely fill their container. And the final thing to think about here is we want to think about the intermolecular forces. So we said before that solids have very strong intermolecular forces. Liquids, they have probably medium, we could say. They're strong, but they're not as strong, okay? So they've got medium intermolecular forces. But gases, we say that they have little to no intermolecular forces, okay? And we talk about ideal gases, and that's saying that the collisions occur and there's no attraction between our two gases. This isn't entirely true, but we're going to say that they have little to no intermolecular forces, and as a result, a visual illustration of a gas would be they're very, very far, very separated atoms, kind of off doing their own thing, not really caring about the others. So there are no attractions, or little to no attractions between them. Now, I'm going to give you guys an opportunity to work some practice problems. Essentially, I'd like you to reproduce some of these things that we've talked about. So, first off, what do we call the forces that hold molecules together? The forces that hold molecules together, so it's one molecule held next to another molecule, this, holding a single molecule. I want to clarify that. If it holds a single molecule in together, it holds it as a molecule. These would be inside forces. These are known as intramolecular, or bonding forces. Okay, intermolecular forces. Intramolecular forces. The forces that keep separate molecules close to each other, so we're talking separate molecules, not a single molecule in the atoms that compose it, but keeping separate molecules nearby, those are the intermolecular forces. Intermolecular forces. And a thing that we have to distinguish here is that inside forces, bonding forces, are much stronger than outside intermolecular forces. Now, complete the table below. We already talked about this in a lot of depth, but solids have a high density, liquids have a medium density, and gases have a low density. In terms of motion, solids are restricted. They vibrate. Liquids move around each other freely. They move around freely around each other. And then gases just freely move. Now the shape of solids, they retain their own shape. Liquids take on the shape of their container. And gases have no specific shape, but they completely fill their container. Okay, so not the same as liquids. Liquids will sit at the bottom because gravity has such a strong effect of their container. Gases will fill the container entirely. Intermolecular force strengths. So first, solids are very strong. Liquids, they are medium strength intermolecular forces, and gases have little to no strength.